Okay, Dragons, it's time to do our review. Here we go. Looking at the graph to the left, which best represents the axis of symmetry and the vertex. The axis of symmetry slices the parabola in half. So if we find our maximum point in this case right here, and we draw a line of symmetry that's vertical, this way right here, we can see that it crosses the x-axis at -2. So since all of these are x equals, I look for ones that say -2. So just knowing that, the answer is between C and D. So we'll eliminate A and B. And now we're looking at the vertex. Again, the vertex is on the line of symmetry, so I just simply need to identify this point here. And from the origin, I move 2 to the left, 4 up. 2 to the left, 4 up. Correct answer is C. Problem number 2. Which graph represents a function with a domain of all real numbers greater than or equal to -4 and less than 1? All right, so domain. Which axis are we dealing with? We're dealing with the x-axis. Domain is x-axis, so we need to be thinking that. So I'm going to highlight the x-axis on all of these. There's the x-axis there, 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 and there. So my eyes should be going left and right, the x-axis. Okay, so now let's see. Where does this graph cross the x-axis? At a -2. I need a -4. Sorry, A, you're gone. How about B? Well, if I take my graph and come down here, it gives me a -3. What did I need? I need a -4. Sorry, B, you're no good. How about C? If I come over here and go straight up, oh my goodness, I actually touch it equal to -4. Closed dot means that I'm equal. And let's check out the 1. So if I come over to this graph right here and drop it down, I have an open circle at 1. That means I'm simply less than 1. I think we have a winner. Okay. Don't be tricked by looking at the range, the y-axis. So maybe if you highlight your x-axis like this, that'll remind you to keep your eyes going left and right. All right, problem number 3. Miller graphed a quadratic function with vertex at 5, -9 that contains the point 0, 66. Okay. Well, we can either well, there's no need to solve for A because it tells me A right here. A is 3. So let's just grab our calculator. Let's make this a calculator problem, okay? So if we come up here and let's see, let's clear all that out. Here we go. If we check the first one, again, I'm not even typing that in. Well, actually I am. If I type in that first one, I got to have something to compare with. Okay, so there's the given function right there. And so now I'm going to just match it up. Alright, so if I go over here, and then I typed it in Y2, it really doesn't matter which one you do. Right? So if I compare A, let's check A. 3x squared minus 30x minus 9. Now if these two are the same, if A matches this right here, when we go to the table, we should have both of these points there. Alright, so let's go to the table. Alright, so we're looking at, do they both have 0, 66? 0, 66 for the original problem. 0, -9 for the one I'm comparing it with. So this one does not work. So sorry, A. So all I'm going to do is go back up here and I'm going to change keep the original problem in there, and now I'm going to type in B and see if it matches up. Alright, so here we go. Do they both have 0.66? 0.66 on the original problem, 0.66 on the, oh, okay. And how about with a vertex of 5, -9? 5, -9. Do I see symmetry around this 5, -9 on both of them? Yep. I see symmetry around this -9. So that's the vertex. So the correct answer is B. Okay. Which equations, problem number 4, which equations graph has a vertex at -2, 3 and contains the point 139. So we're going to do the same thing as we did over and over again, except we have nothing to compare with. We're just going to type this in our y1 and see if it contains those points, but we've got to make sure that we check that this is the vertex. Now, in order to save time, if you want to try the problem, if you haven't done it, pause the video and do that. Otherwise, I'm not going to show you all of them, but just for time. Okay, it's actually going to be this last one. Let me show you why. Alright, so once we do this, does it contain the point 139? Yes, it does. Does it contain the point -2,3? But that's the vertex. -2,3 is the vertex. So I need to come over here and make sure that I see some symmetry around -2,3. And if you notice, I got a pair of 7s surrounding this 3. I got a pair of 19s surrounding this 3. I got a pair of 39s. That means that this is the vertex. So that's why this one is the correct answer, answer D. Check the other ones. They may have both points, but this one is not going to be the vertex on the others. It works on this. Quadratic function is graphed on the grid below. What is the value of A? Well, this is what we've been practicing. We got to go steal the vertex. The vertex is 4, 0, and that's my H and K. And I need to pick another point from the grid. How about 5? You got to be careful on this. This is 5, -8. Look at your scale. Even though this says it's going by 5, each one of these crisscross lines is going to be 1, 2, 3, 4. Yeah, each one of these is going to be a single one. This one didn't show up too good, but there's one right there. Alright, so this is going to be 5, -8. That's my X and Y. Alright? So if we go back over here and we're going to just substitute in right here, Y is -8. X is 5, 5 minus H, which is 4, and if we square that and then we do plus K, which is plus 0, and we just leave the A equals right there. Notice 5 minus 4 is 1, 1 squared is 1, so I really get 1A. It's equal to -8 plus 0. You don't really need to subtract 0 from both sides. You divide by 1. Oh my goodness, guess what? That means A is going to be -8. Number 6, 2 points on a graph of a quadratic. Remember, a quadratic function is a parabola, so it's either doing this or it's doing this. Are shown on the grid below, this grid right here. Okay, what is the equation for the axis of symmetry? Axis of symmetry, once again, splits the difference. It splits 2 points that are reflection. Now, there's no way this can be the vertex because I have a twin horizontally from that. So the question is, how far is it from a -3 to 5? Well, if you take a step starting from -3, one number per step, you got 8 units. These 2 points are 8 units apart. Remember, these points are equal distance from the line of symmetry. So if each of these points is the same distance away from a centrally located vertical line, I got to go halfway. Well, what's half of 8? It's 4. So from either side, I'm going to move 4 units in. Let's count. Starting at 5. 1, 2, 3, 4. That puts me right here. And let's just check the other one. If I start here and at -3 and go 4 to the right, 1, 2, 3, 4. Oh, that puts me right here. So that means that my line of symmetry is going to go right there. I don't know much else about this parabola, but I do know the line of symmetry is going to split these 2 points so that they are the same distance from my line of symmetry. Well, Hooivux. This is a vertical line, so we need to pick things VUX, VUX. I need to pick something that starts with an X. So I'm not going to pick that, those 2 that start with Y. Okay, where does it cross the X-axis? It crosses at 1. I think I should pick A. That's the correct answer. Alright, the next one is we're going to, it's actually a balloon problem. But remember, before we do the balloon, we actually figure out on our calculator what's happening. So here's the, what do we call this? Oh, that's right, it's the parent function, x squared. Alright, you remember what we do here? We're going to steal the parentheses, but then we're going to square it because we're talking quadratic. So just type in the parentheses. Where did I get a negative from? Oh my goodness, that should be a .23. And we're going to square that bad boy. Is there anything else like out front over here? No, that's it. So, alright, here we go. So let's see what happens. We press graph. Here flies the parent. Alright, so by looking at it, we know that we need to be wider. Alright, so if you remember the balloon, what we do is we're going to ask ourselves, is the number inside or outside? Remember, inside is horizontal and outside is vertical. Okay? Remember, inside right here, I before O, and outside I before O. Okay, so that means that alphabetically horizontal, H comes before vertical. Okay, vertical. Alright. So I'm going to pretend like I'm holding my balloon. That point 3 is inside. I'm going to be holding it horizontally. So I'll see my pretend balloon. Okay. But I need to make it wider. So am I going to no, I'm not going to compress it because that would make it narrower. I'm going to take my balloon and that's how I make it wider. So I'm going to do a horizontal stretch. Let's pick B. Alright. Now this is a golf ball problem. These are very popular when it comes to quadratics. So what should we do first? Absolutely, we're going to put this bad boy in a calculator. So there's star rule number 1. If you see an equation, you put it in your calculator, you graph that sucker. And you may say, well, Miss Molly, I already have a picture. Well, that's true, but there might be some details that we need to see better and no better place than on our calculator, because our calculator can actually find this 0 exactly. It can find this maximum point exactly, whereas if we didn't have the calculator, we would have to estimate. So here we go. Which of the following is true? The y-intercept, here's my y-intercept, is 17. Now be careful. This one looks like it's going by 2's. 2, 4, 6, 8, 10, 12, 14. This right here is 15. It's not 17. Sorry. 1, you're close, but we're not playing horseshoes. Alright, an x-intercept. Now if you look over here, an x-intercept is also known as a 0 or a solution. It looks, I mean, this is what 4.25. It looks like that's going to be true, but we can actually prove that by doing our estimation for our second calc. So we graphed it. We're going to do second in calc, and we want to do a 0. All right, so now remember, if you don't see your cursor, you need to look down here and say, oh, right now I'm at 1.5, so my cursor is 1.5, it just happens to be way up here. So I'm going to arrow left, and as you can notice, my x value is coming down and oh, there it is right there. Okay. So I know where it is, but I want to move it. I'm going to check this point right here. So if I just come over here and eventually, oh, there it is. All right. So is it to the left? Is this cursor to the left of my target? Yes, slightly left. So I'm going to press enter, and now I need to move it to the right. So I'm going to go a little bit below that, press enter, and then now I don't want to guess. And guess what it says down here? It says 4.17. So I've verified that this is true. Okay. All right, and the axis of symmetry is 1.75. Now this may be a new thing to you, but go back to second trace, and if you notice right here, it'll find the maximum for you. So this maximum point up here, we're just going to do the same technique. We're going to put a left boundary and a right boundary, but our target is going to be up here. So let's find the maximum. Okay, so I need to be to the left of my vertex, and right now it is not. So I'm going to just move it so that it is, oh, there it is. So it's to the left. It's pretty far to the left, but who cares? So I'm going to press enter, and then I'm going to move it to the other side. I see I don't even need to see my vertex, but I know that it's to the left and the right. And I press enter again, and it says the maximum is 1.57. Ah, great. Axis of symmetry. And I know that the vertex has to have the same value. It does not. So this one is not true. You can even see that one over here. 125 is not even on the parabola. 125 would be right here. So that's a throwaway. So what do I have? 2 and 3? How about answer D? All right, number 9 is we've already done one like that. You're going to pick up your calculator, but you need to make sure that you check for that this is the vertex. All right. So this one's pretty easy. This one is A. So if we go in there and type it, and we go look, what do we have? Do we have a vertex of 4, 1? There's 4, 1. Is it surrounded by reflected outputs? Yeah, I have a couple of 4s surrounding the 1. I have a couple of 13s surrounding the 1. A couple of 28s. So this is the vertex, so that's good. Does it contain the 0.728? Yes, you can see it right there. The answer is A. All right. Next one are just kind of like matching things or thinking problems. All right, so in this particular problem, we have a quadratic, and they decide to get cute on us. They use plus C, but we know originally that this was our K value. And our K value actually moved things up or down. All right, what did A do? A made it, what, open up or down, and it made it wider or narrower. But they're just saying that A is positive. If A is positive, that means that it's opening upward. Remember, a smiley face means you have a positive disposition. Okay, so we know that we need to pick something that opens upward. Well, ladies and gentlemen, there's only one of these that opens up. And if you haven't figured out what the answer is, the value of A is positive, and the value of C is less than 0. Now remember, C was the same thing as K. So why don't we just come in here and say, all right, K is my elevator. K is less than 0. That means that it moved down. Did this smiley face one move down from the original origin? Yes, it did. Correct answer here is going to be B. Okay. This one, another calculator problem. What you're going to do here is they tell you that A is 1/5, so come over here and substitute 1/5. So as you work this particular problem, you have the parent lined up in the first slot, and then you have 1/5. Okay, and remember you're going to copy the parentheses, but in order to compare it to a quadratic, you need to square that as well. And here we go, there's the parent, and this one comes in wider. The answer is B. Almost there. Alright, this is the same thing. Okay, they're saying that P is the quadratic parent. This guy right here is x squared. We know that's the quadratic parent. So that's pretty convenient. We can just leave that one there. And if this is still the quadratic parent, we know that that's x squared as well, but now we're going to subtract 3. So why don't we go down to the next one and take the quadratic parent and do what it says, subtract 3. There's the parent, and the other one comes in below that. So it's shifted down, and the only one that shifted down 3 is G. So that's your review. I do want to say one more thing before I end the video, and I know it went a little bit long, but hey, quality takes time. You're going to have a spiral question, and it's going to be something like this. It's going to go back and talk about inequalities. So, for example, you might be given a picture that's similar to this, and you might be told to say, all right, which one of these is the inequality for this graph? Okay. So, if you notice right here, we have a dashed line, and all of these, or the first two, are less than, and these are greater than. But you got to remember with inequalities, remember you're looking at your B value. Remember whenever you switch the inequalities, if the number in front of y is negative, you're going to switch the sign. So on these two right here, on these two problems right here, because the number in front of the y is negative, this less than symbol will actually switch to greater than. And this one down here, this greater than, will actually have to switch to less than. So if you just go through and you look at the original inequality sign and go, oh, shading below, less than, without considering what kind of numbers you have in front of your y value, you're going to miss the problem, and we don't want you to do that. I didn't mess with these because the number in front of y in these two were positive, so these symbols will not change. So now after I go through and find out which ones are actually my final inequalities, I know that this one is less than or shading below, so B is a possibility. But now D is also a possibility because it is now switched to less than. This one is greater than, it'll stay greater than, it shades above. I don't want that one. This one, when I solve for y, will shift to a greater than, shading above. I don't want that one either. You notice they put that one first with less than. They're trying to trick you. They're trying to get you right there. All right. So as I take a look at this, the question now becomes, well, which one of these that has less than, they're both shading below, which one actually gives me the right slope? So this is where I'm going to have to solve for y. So if I solve for y over here, let me just try this one. Maybe D is the one we want. All right. So I'm going to move my 2x to the other side, and I'll get negative 3y. Okay. I'm going to shift it here in a second. I'm going to go with the original, greater than negative 2x minus 12, and I'm going to divide by a negative. And so I get y. Now I'm going to shift this to less than. And a negative divided by negative is a positive. Okay. So do I have a y-intercept of 4? No, I have a y-intercept of negative 4. Do I have a slope of positive 2/3? No, I have a slope of negative 2/3. So it's not going to be D. It's going to be B. If I solve this one for y, I get 3y. I'm going to subtract 2x from both sides. and divide by 3, which will not change my sign. Notice my slope is a negative 2/3, negative slope, and my slope is a negative, my y-intercept's a negative 4. Let's go with B. Thanks for watching.